Hi, everyone. My name is Carolyn Driedger. I'm hydrologist and outreach coordinator at the USGS Cascades Volcano Observatory in Vancouver, Washington. Happy to be here today, recognizing that Snohomish County, Island County, are some of my favorite parts of the world. So even if I can only be there virtually, that's just terrific. So thank you to the Sno-Isle Library system for putting this together, as well as Liz Westby from the USGS, outreach geologist who has been working hard to assemble this series of talks. So a few weeks ago, Heather Wright spoke to you about the Mount St. Helens 1980 eruption, and she pretty much outlined what happened then. She talked about the geology then and what happened in succeeding eruptions. And it was just great. And it was really nice also to know she was being seen by the hometown crowd, being from Whidbey Island herself. So, but today I want to talk to you about Mount St. Helens in a little bit different way. And we're going to talk about some of the events that happened that led up to the Mount St. Helens eruption and influenced our response to it, as well as what happened then and how it changed people's lives and people's professions. And then we'll go on to talk further about some of its legacies. So I'm going to tell you some stories about just a small fraction of people who took part in this response. And that's really important to say because there were literally probably hundreds to thousands of people who aided with the science and with the search and rescue and other emergency management functions and coordination functions, keeping people safe. So that was all really important. And maybe I'm not even mentioning some of the most important or most valuable contributors to understanding the eruption, but we're going to start with this small fraction. There might be some surprising backstories that you may not be aware of. I think I have a strong appreciation for the connection between people and events, maybe in part because my father was a history teacher, and he always impressed upon us, his students and his children, that it was really important to understand the motivations and the particulars of the personalities of the time as to how they predisposed, what happened in history. And so it's important for us to examine that here to understand Mount St. Helens in perspective. So with due diligence, knowing that I'd be doing some talks and writing a fact sheet with some other people, I did some interviews in 2020 and 2021, even just this past week, with some of the people who worked in Mount St. Helens. And it was kind of like a good time to catch up and to ask them what they had learned and how Mount St. Helens was still influencing their profession and their career today. So you're going to hear some of those stories later on. But we're going to start with what happened with a little bit about people and volcanoes. And some important things to remember about how people experience volcanic eruptions. People have lived with volcanoes for thousands of years, yet their response to eruptions remains, really visceral and really complex. It's for any culture, whether it be the native people here in the Pacific Northwest, a volcanic eruption is a really big deal. And it might be just happen once in a generation or two. That memory gets passed down in oral or written form. It's also just a full sensory overload. If you've experienced a volcanic eruption, you know that there's the sight and the sound and the smell, and the feel of that gritty ash in your hands and your boots and your face and your lips, eyes in particular. There's something really symbolic about volcanic eruptions too, about the magma rising from the bowels of the earth and the eruption being powerful and uncontrollable. And I think pretty often it's thought in some cultures, somebody did something wrong. What brought this eruption on us? It's not a good thing. But I think that that same visceral reaction that it was experienced by early humans is probably felt by 20th century humans today. And there's a lot of approach and avoidance about volcanic eruptions. So we see the Cascades as these gleaming magnets that pull people to their slopes. There's a great little book, a little bit of an offbeat book. I'm not sure that I've ever actually seen it in a local bookstore, but it's by Alan Weltzine. He's a sociologist, and he talks about how volcanoes are so important in forming the identity of a community, and how each volcano has this tributary population that are somewhat loyal to it. He talks about on a more personal level how we have, ascribed some of that, or we have appropriated some of that majesty from these volcanoes for our own personal selves. And it kind of gives us a sense of entitlement, and maybe in the Northwest, a little bit of sense of exceptionalism as well. But if we're going to talk about Mount St. Helens, we need to go back, because back to starting back in the 1950s. We could go back earlier, I suppose, but we'll start with a USGS scientist, Rocky Crandall, who is responsible for our understanding of the enormous magnitude of volcanic mud flows. I'll probably here on talk to them. That's lahars, these big, chunky, murky, muddy, boulder-rich, gooey, cement-like flows that advance rapidly down valley, 30, 40, 50 miles per hour, and inundate everything in their path, which these are quite common, we know. But anyway, so Rocky was working on deposits. He had been assigned by USGS management to map the extent of glacial deposits in the southern Puget Sound area, as was his colleague Don Molyneux, somewhat adjacent, and they worked with their university colleagues in mapping these glacial deposits downstream of Mount Rainier. And here's a couple of photos of them, on the it's my right and the lower left. Not everything was working out as was expected, and it seemed that instead of being on the valley sides, these deposits were all on the valley floor, and it almost looked like they had flowed into place. So Crandall was discussing this with other colleagues, including Don Molyneux, and a light bulb kind of went on in Crandall's head, and he even wrote in his July 25th, 1953 field notebook, he had this radical idea that maybe this deposit was not glacial in origin, it flowed into place. That idea overturned the conventional wisdom of how, that this was actually a giant mud flow, or a lahar, that had flowed into place. And we know it today as the Osceola mud flow, which flowed through time eventually down into the Kent Auburn Valley. So they published this idea, Crandall Water published the idea in 1956, and they were pretty proactive and very prolific with their publications. So there's a 1967 hazard assessment, and there was a 71 professional paper, and a 1973 map. They really got into this. So before long, between this and some other maps, they were doing lots of hazard assessments. And they were becoming known for their hazard assessments. Now, this was really the first geology-based hazard assessment in modern times. So Crandall moved beyond data and hazard. This is really important, because if some of you might be familiar with how state a government publication can be, it's such as a USGS professional paper, and there are very set and very conservative and rigid guidelines on what you can say and how you say it and how you present it. But he really moved beyond the data, and even talking about hazards, and he talked about some recommendations for mitigation. And then he went up to the National Park Service managers and said, you have a problem here. You have a campground that's right in harm's way, and you have the whole Longmire administrative facility that's really at risk from being inundated. So, he was really asking a new normal of us when he wrote these recommendations to install a lahar detection system in critical valleys, and develop a warning and notification system, to establish evacuation plans, and make a plan to lower the lake levels behind dams, make a plan to restrict travel in hazardous areas. And so that was pretty radical. And I think that not too many people saw that and took it too seriously at the time. So similar work was done at Mount St. Helens. And meanwhile, colleague Don Molyneux was looking at volcanic ash layers there. The two of them were comparing notes. They were recognizing that some of the layers at Mount Rainier just were not settling right. And comparing notes, they realized that some of the ash layers at Mount Rainier were from Mount St. Helens, and they began to spend a little more time working at Mount St. Helens. They were actually working simultaneously on these, but they did a lot of work and came up with an amazingly prescient statement. They made wrote a hazard assessment, and in February of 1975, they made this bold statement. Even if there hadn't been an eruption, this might have been the volcanic event of the century that this bold statement was made. That Mount St. Helens, although long dormant since 1857, little known but prominent on the horizon in Southwest Washington, will erupt again before the end of the century. And that was just an amazing statement for them to make in 1975. That was February of 1975. So they really didn't have any other volcanic activity in the Cascades to make them think about it. But it's amazing the difference that a month can make. In March of 1975, around 3 weeks later, geothermal output at Sherman Crater at Mount Baker rose an order of magnitude, and this increase in steam was obvious. A large cauldron, in the Sherman Crater was enlarged. There was lots of gas release. To the chagrin of Steve Malone, there was no seismicity. He's a seismologist. But this was a fascinating place. And I like to think of that 1975 Mount Baker event as a little bit of a dress rehearsal for what happened in 1980. Little did they know, right? That there was going to be a performance, a chance to prove themselves. So this was the first USGS response to heightened volcanic activity in the contiguous US since Mount Lassen in 1917. It was also a real opportunity for scientists to come and test their equipment, set it up, to think about what might happen and look at the possibilities. For myself, I wasn't working for USGS at the time, but our supervisor, Mark Meyer, in a USGS office, glaciology office in Tacoma, was among that group. And it just seemed like it was, the glaciologist and the seismologist and the geologist all working together and contributing ideas. And it was a great opportunity for them to bond. And they also got a taste of what it was like to tell officials that an area, a very popular recreation area, needed to be closed. So I kind of think of that as sort of the get ready. But then we moved down to the Caribbean. So as another influence on the 1980 response, and that was the eruption the events of Guadalupe in 1976. So it seems that this was a great opportunity for scientists around the world, unfortunately, to be exposed to witness some pretty ineffective coordination and communication. And that's not just my opinion. I wasn't even paying attention at the time. I was celebrating the bicentennial of the United States, as probably you were as well, if you're my age. But anyway, this volcano was being studied by multiple groups of scientists. There was minimal pre-eruption monitoring, just a really slow buildup of activity. There was some violence. People were unhappy with being kept out of the area. There were 20 to 25 scientists who were working in multiple teams, and they were giving different interpretations, different scientific interpretations, really poor communication between these working scientists. And they gave conflicting reports to the public officials. There was unlimited access to journalists. And so, the journalists would hear one thing and then another. And there was a controversial evacuation of about 77,000 people. Maybe by some people considered to be erroneous because there was a misinterpretation of whether there was glass in the lava. But with further investigation and years later, maybe that was a warranted activity. Okay, so with Guadalupe, that event actually ended up in a huge investigation with scientists pointing fingers at each other. An outside group coming in to see what had gone wrong. And they said, you really need more coordination and better communication among yourselves and with officials and the news media. So move forward to 1979 as the lead up to Mount St. Helens. There was a more apparent threat here. There had been an eruption in 1971. There was better coordination. There was actually a successful evacuation of several thousand people. So here we went to the other extreme. I guess one could think of it as the mama bear, the papa bear. We're still looking for just the right size chair for that that medium sized bear. Okay, so here they really overly controlled, at least in some opinions, but overly controlled the media, news media communication. This 1971 eruption had really prepped the population as to what a volcanic eruption could be like. So there was some pre-eruption monitoring. There's this rapid buildup of activity, and scientists worked, but the scientists all worked as one group, and so they gained consensus among all the different specialists as to what might happen, and they gave one interpretation to the officials. It was very straightforward. There was good communication between the scientists and the authorities. So there was a single stream of information, and there was no access to the hazard zone and no access to the scientists. The news media didn't like this very much, but in fact, one person threatened to sue, one reporter threatened to sue, and the governor summarily deported him. So maybe that's not quite what we need either at our next eruption, but get set. Let's move forward to 1980. Mount St. Helens was kind of a favorite place for recreation. The public and officials didn't really recognize the hazard, and perhaps they enjoyed it more because of that. The calls of Crandall and Molyneux had not really been heeded. There was a lack of manpower, as we called it in the day, and not a whole lot of motivation, not enough to change programs and divert money. And so often it takes a crisis to do that. So here's the status of volcano response in the Cascade Range as we enter the 1980 eruption. There were no place-based volcano observatories in the Cascades at all, minimal communication with public officials. Some had been done, but not enough. Minimal volcano monitoring. We had just isolated instruments out rather than networks. No valid emergency plan or communication plans or USGS science response plans, community education experience. We're pretty much as scientists siloed into our own scientific disciplines, where the geologists have worked in their own way, seismologists in another, etc. Okay, so let's just put yourself back to 1980. What were the news stories of the day? It seems that there was a big rescue mission for the Iran hostages that had gone awry. It was actually a terrible tragedy. We had the Mariel boat lift, an influx of Cuban refugees that was out of control. All that season, people were concerned with who had shot JR on the big Dallas TV program. So with that background, and when it's a dark, often dark days, rainy days, as we're experiencing for some of this March 2021, the news that Mount St. Helens was doing something interesting was kind of a welcome diversion and kind of an exciting new kind of drama. So go. All right, so the first indication that there was something, going on at Mount St. Helens was noticed by the Pacific Northwest Seismic Network, and that was Steve Malone talks about how one of his workers, saw something unusual, and they just said, okay, it was just one more earthquake to locate. It's probably nothing. And then finally they located it and realized it was under Mount St. Helens. And then a flurry of earthquakes continued, and they began to realize that this might be something more than they had thought. So, within a period of 24, 36, 48, 72 hours, they went from no activity to major activity to putting in instruments on Mount St. Helens and contacting all these different groups. And I remember being in the Tacoma office where we actually had a view of Mount St. Helens on the 8th floor of what was in the Pacific Bank building, I believe. Steve Malone called our boss, Mark Meyer, and said, guess what? We have these earthquakes. And we all discussed it in the hallway and decided that probably nothing would happen. But anyway, Steve did contact people at the USGS, and he talked to Don Molyneux and eventually to Rocky Crandall. The earthquakes continued, but the scientists were in Denver. They didn't recognize what they didn't have the full sense of what was happening there. It wasn't like there was a email or internet where they could trade a lot of data at the time. So, and they were sedimentologists. They were people who looked at layers of rocky debris. I mean, they didn't use rock hammers. They used shovels for their work. And they were unfamiliar with seismology and what this might mean. And so I guess Steve told me that he talked to Don Molyneux, who is a very good handholder. He's a geologist. He said, okay, I'm going to help you with this. I'm going to come out and work with you on this. I'm told that there was another plea too, when it was said that by the people in USGS in Denver, that the people at the seismologists were going bananas. So clearly something big was happening. Well, Don Molyneux came out, eventually Rocky Crandall as well. And there was just an onslaught of news media that met them. It was absolutely overwhelming. Fortunately, the Forest Service used an incident command structure for forest fire response. And that framework worked really well, at least on a local or some regional level, for volcanic eruption also. And that included having joint information, like kind of a joint information center where they could all talk within their own lane of information. So that was greatly helpful. Before all this was done, the Mount St. Helens response would be the biggest news story that the U.S. Geological Survey ever covered. All right, let's go to look at a few personalities as we're moving towards the big catastrophic event on May 18th. So, USGS scientist David Johnston had some harrowing experiences at Augustine volcano in Alaska in the year previous. And so when he came to the region, he was actually in the Pacific Northwest for a scientific meeting, and he came with his conference clothes. He wasn't really prepared to go out in the field, but when all this activity began at Mount St. Helens, he went to Steve Malone and said, "Steve, what can I do?" And he said, and Steve told him that he could watch the seismometers. And finally, after a few days, he said, "All these news people are just over the top and taking my time, my science time. Could you please go down to Mount St. Helens and talk to people there, talk to the news media there?" And Dave was happy to do that and feeling very, very powerfully motivated because of what he had experienced in Alaska. And so a young news reporter, Jeff Renner from King 5 TV in Seattle, was one of the people who frequently talked to David. And again, we go back to Mount Baker, where David had David Johnston and Jeff Renner actually came from similar parts of the country, just not too far apart. Jeff from Wisconsin and David from Northern Illinois. They understood each other. And Jeff had expressed at Mount Baker, he had expressed a lot of interest in volcanoes for his volcano stories. And Dave gave him advice on what to read and told him all about the different kinds of hazards that could be experienced. And they built up a real rapport. And I think that's a kind of a lesson learned, that how valuable it is to train the news media who are going to have to stand in and speak for you on future occasions. All right, so David was a gas geochemist. You can see him using a co-spec to measure gases. And so, lots of things happened. That we had, Heather went over a lot of the physical things that happened, but that the magma was intruding into the volcano. A bulge on the north side was moving outward and destabilizing the slopes, and people were trying to understand what might happen, knowing that there had been some collapses at Mount St. Helens before, but nobody was really sure. That nobody had an idea of the energetics of this. And I want to remind people, when it is asked, well, why couldn't people predict what would happen? Imagine the state of the science back at that time, where there had been practically nobody who had experienced an explosive eruption, within the U.S. Geological Survey. Only the very fluid basaltic eruptions in Hawaii. So there was just not a lot of experience for this. So people worked really hard. There were lots of putting heads together to understand what might occur. But there we are on May 18th, 1980, 8:30. Oh, 8:32 it is. 8:32 in the morning. The south side of the mountain, excuse me, the north side of the mountain collapsed. We had a blast move over it and beyond it and faster than that landslide. And we had a large plume go into the sky. As you see here in this photograph by Bob Krimmel, one of the glaciologists who was used to taking pictures of glaciers, but he did well here with taking pictures of volcanic eruptions as well. So this was just, there was an amazing personal and cultural seismic shift. You know, this was kind of the fulcrum in a lot of people's life stories. You know, what was it like before? Where was I when this happened? And how did I think before about these cascade volcanoes? And do I still see them as benign and recreational opportunity locations, or do I see them as something different? And it's been reported that a lot of people felt depression, a sense of real uneasiness, and being that we were in, you know, still within a Cold War, and there was a threat of, you know, a bomb being dropped. People were, some people have told me that they thought maybe when they heard the boom, 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 that maybe the bomb had been dropped. And there's a lot of uneasiness and people feeling absolutely astonished and overwhelmed. And I think it's summarized well in this newspaper special edition piece from May 25th. But until 2 months ago, in the memory of every living person, Mount St. Helens, shimmering across Spirit Lake, stood as a ready symbol of benign and beautiful nature in the Pacific Northwest. You know, the mountain never will symbolize that again to those who have seen the destruction that has been wrought, or to the thousands whose lives have been wrenched the days, that bright and peaceful, deceptive Sunday morning of May 18th, 1980. So among many people, emergency managers and scientists and the public, the mood, amazement, shock, sadness. There was much work to be done. And we knew that there were more eruptions to come. And at that time, the Forest Service was running flights 24 hours a day over the volcano. And I will tell you later about my experience and what motivated me to work with volcanoes further in USGS. But anyway, I'll just say I had a chance to fly in one of those night flights. And it was a very eerie experience. You couldn't recognize any part of the terrain, even though I was somewhat familiar with the northern side of the mountain. But we knew we had to get back to work, and that wasn't easy. And I can tell you, it was not an easy place to work either, because dust, volcanic ash was everywhere. And volcanic ash, of course, is just these tiny little fragments of broken volcanic rock. And so it's very abrasive, and it gets into, all your facial parts and your boots, and it destroys your camera and your eyeglasses. And it was also just very disorienting to work there where this had changed. You were still so much in awe, let alone having to do the scientific work, but we had to move on. And we had just lost a colleague, David Johnston, when the blast overtook him at a place called Coldwater 2. So Mount St. Helens became somewhat of a master teacher and an ideal lab for volcano studies. And really, I put this in the past tense, but monitoring the volcano and the analysis of deposits has led to so many new insights that were applicable in the Cascades and at volcanoes around the world. The USGS founded the Cascades Volcano Observatory in 1982. We're still in Vancouver at a different location than originally. We have 80 some employees there now working on the Cascade Range. Necessity has bred much cross-pollination among these scientific disciplines. So, we had people like the stream gauger on the left and seismologists trying to understand their respective cultures and terminology, and have people like Rick Hoblet here in the lower left-hand corner. Been a picture by Bill Rose, actually, Michigan Tech. He's, look, they're all looking at a pyroclastic flow there, and then people who were doing surveying. So they all had to kind of come to understanding that all of them had something to give to the other to put the entire three-dimensional puzzle together of the story of Mount St. Helens, and to understand what was going to happen next. Local residents in the world gained a big, profound appreciation for the destructive power of volcanoes, as seen in this destroyed bridge in the Toutle River. Volcanic ash is recognized as a long-term hazard on the ground and to aviation. The first ever health studies of it began in Eastern Washington and later expanded worldwide. Dredging the sediment from downstream rivers continues intermittently even today. And of course, the big question is what we do with all that volcanic ash. So those of us in Southwest Washington are used to looking at big piles of ash along I-5, as well as recognizing that the foundation of the Three Rivers Mall in Longview and other areas are built up from that ash. The same thing happened in Eastern Washington, where volcanic ash was cleaned up and put into, it was buried, basically put into excess wetlands and covered with soil and made into parks and ball fields. I should mention that on the right there, you see the picture of the dredging. That is, they're actually dredging lahar sediment. And remember that the big lahars came downstream on that day, as well as there being a directed blast in a devastated area. So the lahars leave a lot of sediment behind that fills the channels and encourages flooding, and pushes the water out over the landscape. So, and it fills in shipping channels. So it's very important to keep an area dredged. Studies at Mount St. Helens and all the Cascade volcanoes, led to a lot of new insights. We got to understand, people basically fanned out to all the Cascade volcanoes, and that work is still going on today, actually. They mapped the rocky deposits and try to understand, like reading a book, looking at all the different layers, the different chapters of this volcano's history. How explosive is it? How often does it erupt? When did it most recently erupt? Where might be the hazardous areas in the future? And then we produced a generation of hazard assessments. A lot of new ideas and new technology sparked a real revolution in volcano monitoring, instrumentation, and that has really aided our ability to provide volcano warnings. So one of the legacies of the 1980 eruptions is that probably maybe even a few people who are even listening today were field assistants, scientists or field assistants out there doing deformation studies, measuring the width of cracks to see how much the dome was, or the crater floor was deforming. Other people were looking at the earthquakes. Using seismic information, earthquake information, and deformation information, we're actually able to predict some of these smaller explosions that happened after the big event. Steve Malone tells a pretty compelling story about, the first time we had a big eruption. I guess it might have been the May 25th eruption, where they saw some, these little wiggles, extra wiggles on the recorders, turned out just before the explosion happened. And then, later on, I think it was June 12th, he said, oh, there are those wiggles again. I wonder if they really mean something. Another explosion. And then on July 22nd, he talks about how everybody was out in the field working at the volcano. But this time he called the new little proto CVO and said, it's going to happen. We're going to have an event. So probably best told by him. But anyway, that's kind of the evolution of how how we learn and apply information that we learn. So now, understanding volcano behavior has led to, new types of analysis, and um, we're able to take this information when we see that there's a threatening volcano that's perhaps going to awaken. We're able to, for example, on the left with Larry Maston's ASH 3D model, he's able to input NOAA weather data and show if a volcanic eruption happened at that time, where the ash would fall and approximately how much. And then, as Heather Wright showed during the last geology talk, we make event trees where we say, if this happens, then we have this much chance of, this next behavior happening as well. And in that way, we're able to have a more quantitative assessment of what might happen in the future. And of course, there were people out there studying the ecology as well. This barren landscape was quickly transformed into this wonderful mosaic of new and thriving plants. Mount St. Helens inspired this new generation of volcanologists. There were about I think it was around 500 non-USGS scientists who came and worked at Mount St. Helens from I think 70 different locations in the US and around the world after the especially after the 1980 events. So now the Volcano Disaster Assistance Program, which was formed back in the 1990s, it's been to around 70 different crises worldwide, and really strengthened the response, the volcanic response in all those different nations, a lot of different nations, like a dozen different nations, I think they see. So they don't go in and take over, but they help the people, and they're able to get some equipment for them. It is run in cooperation with USAID, the Office of Foreign Disaster Assistance, and it's a wonderful multi-agency program that has saved a lot of lives. And it's actually, with our people going to volcanoes around the world, they're able to bring those new skills and that experience home to the US and make us a stronger program as well. There are many different trainings that happen. It's not uncommon at the USGS Cascades Volcano Observatory to see people coming from other nations, building equipment, learning how it works. There is a program to educate people, young volcanologists, CSAVE program through the University of Hawaii, USGS, VDAP. And so it's been just a terrific experience. In addition to that, between 2013 and the present, the USGS VDAP has sponsored a series of binational exchanges. And I think there have been roughly maybe 13, 14 of them by now. We've had a little, had this gap between past and future, I guess, with the COVID happening. But this has been an extremely useful program where they, as scientists, we get to travel, but the public officials who have to do the policy making and make decisions and be motivated and inspired to prepare their populations around Glacier Peak and Mount Rainier and Baker and St. Helens and on, they don't have a chance to go find out what a volcanic eruption is really about, because, in the Cascades, they're low frequency, but they are high consequence. So we have taken them to Colombia, to Ecuador, on one occasion, most of them to Colombia. And we have public officials, like I see Lorraine Churchill there in the center picture, meeting with a group of students during a student outreach event in Colombia. And then I see people from Washington Emergency Management Division and different county governments as well. And Brian from the Washington State Emergency Management Division, and Karina from the State Geological Survey, and Scott Beeson from Mount Rainier National Park. So all these people it's just been tremendous to see how they have become motivated. They become educated about volcanoes and what they could mean, what eruptions could mean for the Cascade Range. I want to mention also that in 2018, we brought, it was 2018, we brought Ecuadorians and Colombians to the Skagit River area, Darrington, Snohomish County in general, and Jason Bierman, the emergency manager for Snohomish County, gave them a wonderful explanation of what the response was like at the Oso landslide. And the Colombians, Ecuadorians who had experienced Lahars had said, that is so similar to what we've experienced also, and we need to learn together about how we can most effectively deal with landslides that turn into these big Lahar-like gooey messes and entrap a lot of people. So it's been a very profitable program. But not only that, now, as opposed to before, when we had very limited contact with emergency managers, we now have these interagency volcano hazard working groups that were developed back in the 1980s, as soon as people could get away from Mount St. Helens and start looking at their own home areas, starting with Mount Rainier, with emergency manager Bill Loki. He showed us, the value of our all working together and creating a coordination plan. So as early as 1988, he had created a plan with other public officials and some scientists from USGS, and he actually had a little exercise practicing an eruption of Mount Rainier. And everyone at the end got a certificate. I survived the 1988 eruption of Mount Rainier. So, what you're seeing in the picture here, I guess down at the bottom, and I see Patrick Pringle there, some of you may know, and Cynthia Gardner, and other emergency managers from Whatcom, Skagit counties, or Snohomish County. Everyone's working together to get products put in place so that they can help educate their communities. And in the top photo, we have Kirsten Hoffman in the city of Puyallup, a number of people working together during a school Lahar drill in Puyallup in 2019. So at that time, there were about 8,000 school students who practice evacuation in case of Lahar descends the Puyallup Valley. And of course, we have the Ording School District that has been practicing for Lahar evacuation for many years. And I want to point out that we have John Ewart here, and we have Seth Moran, who are both from our previous scientist in charge. And just want to say it's been terrific for us to have a lot of support from management to go beyond the science and make sure that our science is applied. All right, so scientists, officials, members of the public, we've all been working together. It all began in the 1980s with Mount St. Helens, increasing the research about eruption histories and the assembly of hazard assessments, and then going out and showing populations that they had a problem in their backyard. We should talk about this. Beginning of volcano hazard work groups, and there's just an ongoing co-development of volcano coordination plans now. Each one eventually being tested and revised. It's just a never-ending process. There's ongoing development of volcano hazards education products and updating and exercising of plans. On and on it goes. Right, so there's also a USGS alert notification system that is described on our website. You'll get the URL at the end, but this is something that we were lacking in 1980, but it does explain the different levels so that you have something objective to speak to or to look at when we talk about what might happen at a volcano. Now, all that work just helped us tremendously in 2004 to 2008 eruption of Mount St. Helens. And in fact, we had the Mount Baker Glacier Peak work group practicing, getting ready for a big exercise of the plan that we wanted to test in late September 2004. And we were all set to go. But instead, Mount St. Helens reawakened with this smaller eruption. There you see the very explosive beginning of it. It turned into a dome building, relatively mild, gentle, low energy eruption. But that event, it was just amazing because all the people from Baker and the Glacier Peak area came and they helped us, as well as people from Mount Rainier. they all came and helped us with that response, and it made it much easier. We got to respond to a real volcanic eruption rather than just playing one. Okay, so these work groups, and I should say in addition, a lot of people in many agencies are involved, the policymakers, you know, there are teacher workshops, and we work a lot with the news media, the public at risk, you know, park staff. We try to get everyone up to speed about what these volcano issues are, the fact that these are what we call active volcanoes. They're not erupting, but they are active because they have all the processes going on inside and underneath that lead to an eruption. And there's a lot of snow and ice on them that when melted can cause lahars. There's potential for ash to the east. And this is going, well, actually all around the volcano, but maybe most often to the east. So this is like a never-ending job for us to work with everybody, you know, and especially with lots of changes of personnel. I want to mention also that with the teacher workshop at Mount Rainier for many years, for some reason, we had a lot of Whidbey Island teachers. I think we probably had a dozen Whidbey Island science teachers come to learn about hazards at Mount Rainier. And we expanded that information to the Cascades also. So some of those responders of 1980 continue to train and support a younger generation. You can see Patrick Pringle, who was eventually left USGS and went on to work with the State Geological Survey and then to become an award-winning teacher down in the Centralia Community College. And Dan Miller, who was one of a colleague with Rocky Crandall, who later took over the VDAP and responded to many foreign eruptions. And then Rocky Crandall on the right, and probably one of Rocky's last visits to the field, looking at the lahar deposits in the Puyallup River Valley. So I told you that I interviewed some people and asked them some questions, and I got a few quotes from them. And they, for example, retired UW seismologist Steve Malone said, you know, Mount St. Helens forced the acceleration of new equipment use and analysis. And he has a very in-depth and compelling story to tell about putting a new system online on March 1st that would telemeter data, but they didn't have the software to do the analysis of it. And so they had to still go back to the volcano and rely on putting in recorders that they had to go back and visit to retrieve the data. You know, they weren't seeing it in real time, in other words. He mentioned that Mount St. Helens was just a career-defining moment. He'd always been interested in volcanoes, but you know, this ever more so. He knows how we've improved the monitoring systems as a result of Mount St. Helens and how this has really accelerated our ability to do volcano seismology at volcanoes all around the world. And so many groups, students, staff at the Pacific Northwest Seismic Network, USGS, you know, university scientists, people in other nations, all have worked together to improve our ability to collect the data, to analyze it, and understand its meaning. He also noted, this is kind of interesting, he noted that there's real value in doing exotic seismology. That is earthquakes that are caused by things other than the normal tectonic shaking of the earth, and like, you know, caused by landslides and glacier movement and deep tremor. And you know, deep tremor, he noted, is, you know, that's what we're seeing with these slow moving earthquakes, slow moving quakes that we see from time to time under the Cascadia, within this Cascadia subduction zone. You know, this information, it's not collected just because it's interesting or fun. It's because it's really useful and leads to insights down the road. Retired emergency manager Bill Loki told me that in emergency management, we can draw a direct line from lessons that we learned at Mount St. Helens to our current volcanic hazard planning efforts at the other Cascade volcanoes. And he noted that we learned the importance of monitoring volcanoes and of scientists and everybody working together before an eruption. If you know Bill Loki and you know how passionate he gets about talking emergency management, he kept telling me, emergency management, it's a team sport. It's a team sport, Carolyn. Got to do it all together. The Mount St. Helens response was so complex. It's been very meaningful and helpful to the profession of emergency management more broadly, because was very complex. It was long lasting. It touched so many different professions and agencies. And there was the Corps of Engineers involved in mitigation efforts, and scientists, and yeah, all different kinds of scientists actually. The Forest Service as the land managers, and there was search and rescue, and all different aspects of emergency management. So a lot of what happened at Mount St. Helens has been documented in the literature of how, like starting from nothing, starting from scratch, moving forward and creating a complex and working emergency management interagency, system. It's given as one of the examples of how, an organic start can be, what it evolves to, and therefore maybe it's a good example of what's needed in the future. I like this quote by Les Nelson, that the Cowlitz County Sheriff, that the jurisdictional boundaries were no longer of mutual interest because we had mutual hazards. Retired King TV meteorologist Jeff Renner told me that Mount St. Helens reawakening and the ultimate eruption and the public's fascination in that ongoing story led the Northwest journalism to evolve in a way that really encouraged strong science and environmental reporting for decades to come. And you might remember that there were FCC regulations of the time that said that you will talk about local events, and that certainly encouraged Jeff to talk about Mount St. Helens, and others to talk about Northwest events and features of interest. He noted that as journalists, they felt a really strong sense of responsibility to tell the story of the volcano accurately, and in context, really understand the processes, know what they were talking about, and to be worthy of the confidence of the scientists and our colleagues. He said that working with scientists Mount Baker, steam events in the 1970s trained him and others how to work effectively with scientists. And that gave a head start to their working with scientists in 1980. David Johnston recognized the importance of not just doing science, but of communicating to the public. So all those interviews done with Jeff and others were of value. Retired NOAA warning coordination meteorologist for the National Weather Service, Seattle, Ted Beener, says, in 1980, we didn't even have a volcano code for aviators. So we just warned them about dust in the air. So that's been changed. We now have a volcano code. The threat to flyways has been established. He notes that the volcano alerts have been changed. The whole system has been changed so that it's a lot more effective and reaches people directly rather than having to go in some sort of a daisy chain manner of people, one person informing another. He notes also that there's a new weather station that was put in sometime after the eruption, recognizing that they really didn't have enough weather stations in Southwest Washington to predict where the ash would travel. So that was a real coup to be able to get that put in. So in 1982, Congress preserved a really unique landscape for the public use and future study. Susan Saw, from here in Vancouver, was part of the Mount St. Helens Volcano Protective Association. And so that the protection for the monument through the creation of Mount St. Helens National Volcanic Monument, it was really a decades old cause. It began in the 1930s, it was accelerated in the 1970s, and by 1980, she was leading hikes to the Mount St. Helens area in March of 1980, so that people could get to know the area, love it, and then advocate for its protection. But it's great to have the National Monument. We can build museums and do interpretation. There are fewer residents at risk having basically a park here. And so now there are many opportunities for visits and learning through the Mount St. Helens National Volcanic Monument and through the Mount St. Helens Institute, both of which I suggest you look at carefully to see the opportunities. At that time also, it has to be remembered that there were new ways of doing interpretation. And so many young people came to Mount St. Helens, and so there were very innovative exhibits that were put in there. And now I want to tell you about briefly in a few slides about what has motivated me. And, I had been working in a USGS glaciology office, and I made a switch, came to CBO at one point, but what motivated that? And probably was events of May 17th and 18th of 1980, and where I was aiding colleague Mindy Brugman, who is now a meteorologist in Canada. There she is. She was doing a project on Mount St. Helens, looking at at the movement of the Shoestring Glacier. So she asked my help. I went down with her on the 17th, never guessing what it would lead to. I thought I was in for a day of field work and surveying. But first we went to Coldwater 2. When we went to Timberline, we went to Coldwater 2. Here's Mindy looking at a camera that was set up there. This is the afternoon of May 17th. Of course, I had to look at the camera as well, time-lapse camera. And Harry Glicken was there. He was directing the volcano from the director's chair. I think the mood was fairly light there. Mindy here examining the laser ranger. This is the device that she had brought down from the glaciology office, where we needed it to make very precise measurements of glaciers, but it was thought that it would be helpful here as well. And it was. And she showed how it should be used. David Johnson was catching up on some field notes at Coldwater 2. And around, David kept saying, you know, it's not really safe to be here. I know you want to stay here and get a helicopter over to the Shoestring Glacier the next day, but I think that you should go home and come back the next day, which was not what we wanted to hear, but we heeded his advice. And we left, and here's one of the last shots of Mount St. Helens intact, about 9 o'clock the night before on May 17th, 1980, SR 504 as it used to be. The next morning, Mindy and I attended a meeting, Sunday morning meeting, and then at the little proto observatory, and then drove up I-5. Dan Miller was a mile or so ahead of us in his own vehicle, headed for Mount St. Helens. And Mindy and I were behind him, and we watched in fascination. And I can't say it was really horror at that point, because it took a long time for the notion to set in that we might be losing some people with what was occurring. But we saw that a large cloud form on the north side of the volcano, and it kept on expanding northward and going over the hills to the north. And then we watched the large plume form out the top of the volcano. We were stunned with what was happening, but we quickly headed back to the Volcano Observatory and began working with the news media, where there was just lots of chaos, as it is at the beginning of about any serious crisis, people not really knowing exactly what's going on. And Dan Miller was getting reports from the field, and he was writing them down, and Mindy and I were writing them down and passing them on to other members of the news media who called. Telephone was the only mechanism for making contact at the time. It was all very sobering. We derived a lot of energy from knowing that we just needed to push forward, and I guess we were on adrenaline. There was one of those no food days. Everyone kept saying this guy, Dick Richard Fisk, is going to tell us how to do news media correctly, because he was at Guadalupe and he was at St. Vincent, and he's seen the two extremes. So we hope we're doing this right. And he's going to write a paper about it, which he eventually did. Here you see some folks from, there's a lot of pensive moods in those next few days working in that little observatory. There's Don Swanson and Richard Waite, who wrote the eyewitness account book. I'm not sure who this gentleman is. Keith Stoffel, who was with his wife in a plane over Mount St. Helens when it erupted. And here's driving. I was living in Tacoma, living on Vashon Island, and driving home up I-5 and watching the truckers just kind of take things into their own hands, and they kept the traffic moving really slowly. They moved at a very slow pace, a few miles an hour, and nobody could go faster than them, because if they did, they would whip up a lot of ash, as you see in the picture on the right. That little car, little government Valiant, we called it Prince Valiant, and it took us a lot of places, volcanic ash and lahar deposits. So with those I-5 drivers, we have all had to adjust, from viewing volcanoes as benign to features that can harm. from seeing them as isolated, or having just isolated monitoring, to full networks, from scientists siloing in our offices to working in partnership to meet societal needs, from working in isolation from emergency managers to working and planning with them, even embedding in their offices sometimes to understand their culture and what we needed to do to get along. From news media avoidance, perhaps, the scientists, to really encouraging the news media to work with us. From accepting an uneducated public to educating them. The lessons for us all have to remain vigilant. As scientists, we need to establish our networking, monitoring networks. We have to plan with many different groups for the next eruption, and never forget that it's going to happen. For budding volcanologists, I'd say that volcanology is about rocks, but it's a means to an end. So it really means, and that end is keeping society safe. To all of you who have witnessed volcanic eruptions, if you have a Mount St. Helens story, write it down for future generations and record it. For all, learn about the hazards to your community and inquire of the public officials about what they're doing in your community, what plans they've made, and plan and prepare your family and community. And importantly, abstain from wishful thinking. Visit our website. And my colleague Liz Westby and Wendy Stovall and others around the Volcano Hazards Program do a great job with their social media posts. So check out USGS Volcanoes on Facebook and Twitter and Instagram. And see our regular activity reports that come out every Friday afternoon. And you can actually sign up to have these sent to you automatically if you wish. So thank you so much. And thank everybody who's out there listening, who participated in this eruption and brought us into the 21st century. And thanks again to the Sno-Isle Library System for all your help in putting this together. Visit our website, and you can see the little fact sheet that was written this year for the big anniversary. See the breaking news there about a big Reddit session on May 18th as well. All right, thanks all.